Hello, calculus students. If you've been having trouble with number 97 and 98, here's one more example of a velocity and position problem that's very similar to what's on your homework. And so this time I just made this up. Somebody standing on top of Half Dome throws a heavy ball off the rock down to the valley below. We're giving an initial velocity of positive 30 feet per second. And the height of Half Dome above the valley floor is about 4,800 feet. And so you can imagine them up here tossing it down. But what happens here is we're going to be using the equation S at t equals, and they give this to you in the book, negative 16 t squared plus the velocity initial plus the initial distance s. So whatever that happens to be. And so we got to plug a few of these numbers in. The first number, 30 feet per second, is our initial velocity. It's going to come right here for VI. And the initial distance is 4,800 feet, so that's going to go right there. So to answer the first part of part A, determine the position and velocity functions. The first one, S at t, is going to equal negative 16 t squared plus VI is going to be 30t, plus the initial distance S sub 0 is 4,800 feet. So there's our position equation. Next it wants us to find the velocity function for the ball. Well, one of the main things we learned this last class was that velocity is going to be the derivative of your position equation. So here we have our position equation. If we want velocity, that is going to be the same thing as the derivative s prime at t, which, taking the derivative of this polynomial is actually fairly easy. You use the power rule. 2 times negative 16 gives you negative 32. T squared, lower the power by 1, just becomes t, plus derivative of 30t. It's a linear function, so it's just the constant in front. And there we have our velocity function. S prime at t equals negative 32t plus 30. Alright, so we got A done. Part B, determine the average velocity over the time interval 3 seconds to 4 seconds. So this is basically just the slope between 2 points. That's your average velocity. So we have to find those 2 points. So for letter B, the first point is going to be at time equals 3 seconds. And then we've got to figure out how high is this ball at 3 seconds. That's best done on your calculator. Since it's a position, you're going to be using this equation right here. Put that into your calculator and it can tell you what that is really, really easily. For me, I'm going to use a website on the internet called wolframalpha.com. It can do all the math you want. And so I'm going to tell it when x equals 3, and it should be able to give me the answer right away. At x equals 3, the solution is 4,746 feet. So I'll come back, and we know right now that this one is 4,000. Oh, I forgot the number. 746. 746. So that's our first point. We need the second point, which is going to be at time equals 4. And so I'll go back here, scroll up, time equals 4. It'll think for a while and give us 4,664. 4,664. And so all we have to do to find the average velocity is find the slope between these 2 points, subtract the y's, subtract the x's. I'll let you do that. That's not too hard to do. Next, letter C. What is the instantaneous velocity of the ball at t equals 4 seconds? So this time it's instantaneous velocity, not average velocity, and since it's instantaneous, it's the slope at one point, which is basically the definition of the derivative, which we already did. It's the velocity at t. So we're going to be doing the velocity function, and we want to know it at 4 seconds. So we're going to plug in 4 to the velocity equation, which will give us negative 32 times 4 plus 30. So that just shows you what the equation would look like. If I was going to do that, I would plug that into my calculator. I'd put this equation into y equals, go to the table and plug in 4, and it will give you the answer there for how fast it's going at 4 seconds. That's probably the easiest way to do that one. Letter D asks, how long does it take for the ball to hit the ground? And so you have to be able to interpret that hit the ground means the height is 0, which means the position equation, this whole thing here, is equal to 0 because the height is 0. And so you don't plug it into t. That's one mistake some people might make, is trying to plug it into t. T stands for time. The whole function s at t, though, is measured in feet, and so that's where we're going to put 0 equals negative 16t squared plus 30t plus 4,800. There's a number of ways that you can solve that. The easiest would be to put this into your calculator in y equals all of this, and then graph it and use the 0 function. If you hit second trace, it's second calc, you can go down to 0, follow the instructions, it'll prompt you for a few things, and it will do it for you. I don't have a TI-83 with me right now, so I need to go to Wolfram Alpha. Instead of y, I can put 0, get rid of the x equals 4, and it will solve that for me. And you can see you got a nice parabola here upside down that shows us what that function looks like. It's got 2 red dots where the solutions are. Looks like it's going to be 18 something. And so if I scroll down, it should give that to me somewhere. I'm going to tell it to show me the approximate forms. And right there we have it, 18.283. So t equals 18.283 seconds. It's quite something. If you throw a ball off of Half Dome, it would take about 18 seconds to hit the ground. That'd be a long time if you were counting. What is the last question? What is the velocity of the ball at impact? So it hits the ground at 18 seconds. How fast is it going? Well, if we're asking how fast is it going at one single point, we have to use our derivative, s prime at t. And so we'll be doing s prime. And this time, if we want to know at impact, that's 18.283 seconds. So we'll put in 18. I'll shorten that to 18.3 because I'm running out of room. Equals negative 32 times 18.3 plus 30. And you can evaluate that, or like I said, hopefully you have that plugged into your calculator, and then you can just go to your table, type in 18.3, and it will give you the number, and that is how far it's going. Just remember that that will be, whatever your answer is, it will be in feet per second, because it is a velocity. Those are the units for speed with what we're measuring in. Hope that helps you, and good luck on number 97 and 98.